Hey guys, this is a teardown of a Hive Lighting WASP 100C plasma light. I got this as part of a cross-promo deal with Hive Lighting. They backed my Chronos 1.4 Kickstarter and I backed their WASP 100C. 100C is a 100 watt LED light, sort of similar to this. And I'll be getting 4 of those in exchange for them getting one Chronos 1.4, and I'll use those sort of as general lighting for getting better lighting on YouTube videos. Anyway, this is a 250 watt RF excited plasma lamp. It's quite a unique technology. You don't really see this very much. I'm sure there's going to be some nice RF goodness in this. So this basically consists of a 28 volt DC power supply, the head which has the RF generator in the bottom, a few cables, uses the mains cable with a switch, and a DC cable that is this, don't know what these are called. These are like a cable common in the theater industry. The WASP 100C LED lights aren't available yet, so they just lent me this for teardown. So, on this side, this is the actual lighting module. It's got a color temperature control. You can adjust it from sort of like 4800 Kelvin up to 6500. So you can see a little bit of the RF cabling in there. There's sort of a guard protecting it. The actual light itself is a little bit hard to see in there. It's that little module, little bulb at the very end. I'm sure we'll get a better view of that later. Yeah, so it takes 28 volt DC, 10 amps. This looks really, really nice. I believe this produces a very directed beam pattern. This also comes with some accessories, some barn doors, and I believe this is a bunch of filters. Yeah, these are some different filters for, I guess, dispersing the light in different ways. And it also has a whole bunch of sort of dispersion filters, and these are kind of stuck together. But yeah, these will disperse the light into much wider beams than the stock reflector has. And there's different versions. There's spot, super wide, wide, and medium. Let's see how this thing works. It seems to take a few seconds to start. There we go. Very dim bluish initially during warm-up, which is pretty normal for these high-intensity discharge type lamps. You're drawing pretty low, only about 70 watts right now. Oh, now there it goes up. Starting to become brighter. Definitely very bluish in color at the moment. Currently at 276 watts. And getting even bluer now. Oh, there we go. Must have evaporated one of the components in the lamp. Yep. Oh yeah, now it's getting really bright. And pretty much, yeah, it's pretty much white now. There we go. That seems to be in normal operation. And yep, that is really bright. Drawing 290 watts. I'd say that's working really well. So at 1 meter in front of the lamp, we are getting about 130,000 lux. That's about the intensity of noonday sunlight at the equator. That's really good. It's really good for high-speed filming. You can get a lot of light especially onto a small subject. Let's try out the variable color temperature. I was thinking they were initially doing this with a rotating wheel in front of the lamp that would change it would be a filter that would just remove some of the light to change the color temperature, but that's not the case. This is actually just a pot. You turn it down. It takes a few seconds, but eventually the color will change. camera's probably compensating for this, but this is definitely becoming much more of a like a 6500 Kelvin rather than the about 5000 it was before. Yeah, it's definitely much bluer now. Also, it looks like the power consumption has dropped a lot. It was 278 watts before, now it's 195, so I'm thinking this is really just a power control. Let's bring it up to sort of mid 5600. Yep, power is changing. So it appears that the color temperature is just a power control, and it looks like when the lamp runs at lower power it gets cooler, and some of the red emitting components in the lamp condense or partially condense, reducing the amount of red light produced. It's actually a really good way of doing it. Let's see if we turn it all the way down to, what is that, to moonlight. What is that going to do? Oh yeah, that goes way down. That's one thing they don't tell you, or I'm not sure if they tell you or not, but it wasn't made obvious anywhere that the power goes way down when you turn the color temperature down. Not really a major thing though, you don't really often use it at super blue lights like this. Yeah, so it looks like moonlight is about 150 watts, 6500K is about 200, 5600 is around 240 or 230 or something like that, and then full power is about 280. So I've locked the white balance here. Let's see how the color changes, see if we can get a better view of how the color changes. So this is at moonlight. Now we'll turn it all the way up to 4800 or 4600 Kelvin or whatever it is. Yep, that definitely changed and definitely got a lot brighter. No real glow to see at all like you normally see in a discharge lamp. Normally the arc tube is glowing brightly, but yeah, this doesn't run that hot. Comes apart pretty easily after removing a few screws and the mounting. That is really simple construction inside. It's basically just a reflector. It looks like this is made out of aluminum. A bit of electronics here for the pot, and then just the RF generator on a big heatsink at the bottom. That is really simple. So it looks like the reflector is made by a company called Phoenix. Some part number scratched on the side of it there. You might just be able to read that. Construction's pretty good inside. There's a DC to DC converter here, 14 to 60 volts down to 12 volts. That's almost certainly to generate a voltage to run for the pot, which provides, I'm assuming, an analog signal to the RF generator to adjust the power. Not a massive fan of the connections using these like push-in connectors, but that's a minor complaint. A few RF suppression chokes for passing EMI, little LED. Yep, there's not much at all in this. Here's the RF connection. Looks like a N connector, and a fully, very nicely shielded coax running up this protective shroud on the back, and then into the lighting module. Overall, I really like the construction of this. It's simply built. It's easy to open up for service. Nice, good, robust connectors on this. These are used all over the place in theater. Yeah, the only complaint, really minor one, is these wire terminations, or wire connections. Now, they said they didn't want me to take this apart any further because something to do with RF generator certification. However, they have provided me with a scrap RF generator and light module for teardown. So let's start taking a look at these. I'm sure we'll have some really nice RF porn in there. The RF generator they sent seems to be an old engineering sample. Mentions here not to pull on the wires too much. Nice warranty void sticker that we're going to void. And someone's decided to be like the dickheads in China who scrape the numbers off chips and try to obscure what this is. But it took me literally 2 minutes on Google image search to figure out that it's made by a company called Luxim and is likely the ENT31-02. Actually, it is, because it says right there it's used in the WASP plasma par. Yeah. What does it say? Yeah, it's exactly the same specs, 28 volts, 10 amps. See a really high CRI 94. Color temperature is about the same as they mentioned on the side of the lamp. So, yep, I think this is the one. I haven't been able to figure out what frequency this runs at, but according to the datasheet for the general purpose lighting version of this, couldn't find the datasheet for the entertainment specific one, but the general purpose one basically says this is a small quartz capsule that has basically the same constituents or materials in it that a normal metal halide does. So it's going to be argon gas and then various metal salts like sodium iodide and scandium iodide and various different ones to produce different colors. It's surrounded by a ceramic piece, and according to the datasheet and the patent, which I've linked in the video description, this forms an RF resonant cavity, a dielectric RF resonant cavity, which concentrates the RF energy from the generator at the point at the center of the capsule, which ignites the gas, and then the heat evaporates the metal salts, and those actually produce most of the light. Housing is die cast, and on the back there's a really nice, completely shielded RF or coax cable. Looks like it's completely impregnated with solder, 100% all the way down. Big RF connector. Yeah, let's see if we can remove these clamps and see what's in this. It's moving a little bit, so I don't want to crack this though. Wondering how you get this out. Yep, there it is now. Wiggling a little bit. I'm just going to pull off the RF connector and see if that yields anything. Okay. There we go. So this is just some sort of I don't know what you call this, permanently installed connector, because there's a contact down in there. Didn't really help getting any further in though. I don't see any screws, so I'm just going to keep wiggling that and see if it comes out. Looks like we got it. Yeah, it's sort of just wedged in there. There we go. Oh yeah, wedged in there with some sort of EMI gasket. There's the RF input. This is, yeah, just basically a big block of ceramic with probably different types of ceramic with certain permittivities to direct the RF energy up into the module. But yeah, actually, yeah, this is definitely metal, or at least metal plated. Around the outside, yeah, is this some sort of RF gasket? Yeah, this just comes apart, so I'm not going to pull that off. There's a putty here that's probably used to secure it. So I'm guessing they apply the putty, put that gasket on, then push this in there. Yeah, this is definitely sort of it decreases in diameter as you go down, so that sort of holds it in place. Yeah, I can sort of see why they didn't want me to take the other good one apart, because he probably wouldn't. Like, this is slid up, it seems, as they put it in. It doesn't look like we couldn't just put it back together though. If we can get the RF generator working, it might be interesting to try to power this up. But yeah, not much else more we can see here without, of course, cracking this open. And even then, you wouldn't really see anything. It's just different types of ceramic put together. The patent drawing has some drawings of how this actually works. If you go check that out, I've got a link in the video description. If you look at the sort of center, near the center of the capsule, you can see a little bit of mercury in there. That's one of the constituents. That, I believe, produces a lot of the sort of bluish and greenish light, and then the iodides produce some of the red, and they probably have a clever combination of various metal salts that produce the very high color rendering index, basically produce light continuously over the spectra, over the whole visible spectrum. I'm wondering if there's a hole up here, and that's sort of aligned with this connector. I'm wondering if there's actually a pin or antenna that goes all the way up there. Can't really see. I've tried to pull this out, and it doesn't seem to want to come out. And there's also more of this RF gasket or sealing material on the bottom as well. Because that's the entire RF grounding path seems to be through these seals. It doesn't seem to actually directly touch, or the metal doesn't directly touch. It has to go through all of these gaskets to get to the case, which is the RF ground. Don't need that anymore. And, oh, wrong screwdriver. Oh, case is sort of popping off. And something's holding this. There we go. Whoa, look at that. Inside the RF generator, we don't have all the beautiful RF porn you often find in something like a signal generator or a spectrum analyzer. Basically have a big RF power transistor, BLF6G10. According to the datasheet, this is designed for cell phone base stations running at the 700 megahertz to 1 gigahertz range. Going on to this is the gate, that's the drain, and the source is the case or ground. Looks like the RF input from that comes through another amplifier, through some various components, what I think is a multi-stage LC filter, or RC or LC of some sort of filter, that takes the input from the, what's probably some sort of VCO or RF generator. Power comes in from the top over here. There's a whole room for a whole ton of capacitors for to allow them to hopefully get the EMI down. So it goes across. There's room for even more filters. Then it goes to, this is part of the RF circuit. Here's a shot out of the RF circuit out of the datasheet. It looks, of course, it looks almost exactly like what they've implemented here. Back on the left, we have a PIC 18 micro that just runs the show, and a bit of analog stuff, some comparators or op amps and such. I haven't been able to figure out what the RF generator here is. The part number is labeled MSAD, and on the next line SLYB. So if someone wants to try to look that up and figure out what part number it is, yeah, let us know. Probably a programming header for the micro. Yeah, it's not a huge amount in this. All of the leads over here, all of them have been tied together with looks like a wire nut, and then there's just one lead. So I'm figuring I'm going to hook this up to the lamp, put the lamp back together, and try to power this up, see if it'll run. And I'll just give a few detail shots for those who want to look at this. Looks like they've separated out the two boards. There's a line here where it's cut. This seems to be just a normal FR4, and this is probably, looks obviously is one of those Rogers or other RF rated PCBs. And it seems for shielding, they just have these little bits with long paths so they can sort of shield the high power RF from getting into the small signal area and getting out the wires. Oh, didn't check under the lid before. It looks like there's a really nice sort of printed RF gasket there. Yeah, some sort of it's a very pretty hard ink or glue or something that's probably filled with metal shavings, metal filings for conductivity. All hooked up to power, got this set to 28 volts. Let's turn it on. I don't expect it to do anything. 28 volts, no current. Oh, it's drawing something. Oh, it's on. And I have this set up to take a FFT. Yep, let's just single that so we can see the frequency. Hey, that's working. Actually, I should probably turn this off because this is going to overheat. Yeah, this is going to overheat if I don't cool it, but we got a frequency reading. What do we have here? So it runs at 436 megahertz, so that makes sense. That's in the ISM band. That is a lot of radiation. Like, we're talking about that little antenna is picking up about 120 millivolts peak to peak into 50 ohms. So this thing radiates a lot. I'm curious as to how this thing passes EMI. Wonder if they passed it as an intentional radiator. Got this thing on a proper heatsink now. Also got a glass in front of the lamp just in case the arc capsule decides to explode. I don't want red hot glowing shards of quartz all over the desk starting fires. Let's give this thing a longer run now. There we go. Looks like the RF power is sort of varying. Wow, that's a lot of signal. That's like over a volt on that antenna. How does this thing pass EMI? I'm interested in hearing about that. So we've got a sort of a slightly varying RF power, modulating at about the kilohertz range. Let's check the current. Seems about right. Still somewhat blue. Yeah, the generator seems to be modulating the RF output to maintain constant power, to adjust the power. It seems to be running pretty much at full power. It's about 28 volts at about 10 amps. It's about the same power we were getting before. Nice and bright. Generator is staying cool. Yeah, that is definitely a very, very intense point source. I suppose it's also possible that me opening this lamp and then putting it back together has affected the radiation performance, but this is still a lot of power being radiated. Very slightly modulated. Modulation frequency is about 100 kilohertz or so. Yeah, every 20 microseconds, or 10 microseconds approximately. It was cool seeing that light run and seeing the inside of that RF generator. The only other thing left in this is the power supply, but I'm not going to bother to tear this down because number one, it's just a 28 volt DC power supply. It's not that interesting. Number two, I've been told it's potted to maintain the IP67 rating, so no way I could really tear it down anyway. It makes sense having this IP67 because this is used outdoors on film sets. It may be left sitting on the ground. It could get rained on, so yeah, this definitely has to be waterproof. One other thing I noticed was odd. This switch, I figure this was something you just bought off the shelf, but it actually says Hive on it. I mean, this is one of the things on the system I would have expected just to have been bought off the shelf. You wouldn't have to make this custom. I'm wondering why they chose to make the switch, have a custom-made switch housing made. I'll have a much more detailed review and demo of this, taking some high-speed shots later. Click here for that video once that's released. Anyway, hope you like this teardown of the Hive Lighting WASP 250 filming light. Thanks for watching.